Hi everybody, these are our video for where are the moon and the sun, our worksheet that we did. This is very important for our preparation for our moon test. And just to kind of start with, just want to kind of point out, we've built our moon finder. And a couple things we need to remember about the moon finder, even though it really doesn't work like this except for maybe 1-2 days of the year. We're going to have 6 a.m. be exactly east, west be 6 p.m., and local noon is going to be right at 12 noon, which we know really doesn't happen a whole lot, but it works for the questions we're going to ask. The thing that we need to do is think of this right here as our ecliptic line. So that's important for question 1. So this one says, draw where the sun would be located at 12 p.m. Well, all we got to do is look at our moon finder, and if I draw an ecliptic right here down below, there's a quick ecliptic, and there is where the sun is at 12 p.m., just like you see it on your moon finder. Okay? Then it says, add to the last model where you would find a first quarter moon on the ecliptic at this time. Well, a first quarter moon is going to be right down here just coming up. So really, you probably wouldn't see it for a little while longer until the sun moves through the day and the first quarter moon rises. So on this one, we would want to write the first quarter moon as being right there, because this on our ecliptic is where that is on that. Okay? Then it says draw a new model showing where the sun and moon would be in 3 hours. Okay, remember, as we move through, each of these kind of spokes, if you will, covers a 3-hour period of time. So in 3 hours, the sun's now going to be at the 3 o'clock position. And notice that the first quarter now has moved much higher up in the sky. You would be able to see it in the afternoon hours, which we know we can see waxing moons in the afternoon. So if I'm going to redraw that, now I just make myself a new ecliptic, which I'll draw below the last one. And now we just have to move the sun right to there, and the moon has come over here, and notice we're still at pretty much a 90-degree angle right there. Didn't draw it perfect, but you get the idea. Okay? Question number 4. Draw a new model and show where the first quarter moon would appear at 6 p.m. Explain how long you'd be able to see the moon that night, and explain your reasoning. So again, we've just got to take this and move at 6 p.m. Remember, the sun is always our time minder on this. So here's our sun. It's at 6 p.m. And if we draw that, we're now just going to do yet another ecliptic. Now the sun's right here, and the first quarter moon is right there. Now the second part of the question is what part of the, how long you'd be able to see this moon at night? Well, it's 6 o'clock right when the sun's going down. The first quarter moon is really high in the sky, and it's directly south. If 3 hours goes by till 9 p.m., we're still going to be able to see the first quarter moon. It isn't going to be able to be until midnight. Notice the sun's down here opposite of 12 noon. It isn't going to be till midnight where the first quarter moon actually starts to go down and out of sight. Remember, everything up here is stuff we can see. So on the question of when we'll be able to see it, we're going to be able to see it during the early evening hours. 8 o'clock is fairly early evening. 9 o'clock, a little bit later, but not too bad. But by midnight, we can't see it. And remember, we probably wouldn't be able to see it even when we're right there because of all the things that obstruct our vision, like mountains and trees and things like that. That's pretty low in the sky. Next question, 5. It says, draw a new model showing the sun and a third quarter moon when it is 12 p.m. So once again, we go right back here and we go to 12 p.m., but now we want a third quarter moon. Well, remember before when it's first quarter moon, we drew that. So now we're going to go back to this one. This is where the first quarter moon would be. Well, we'll just take that out. A third quarter moon's going to be right over here. And again, we're just there, 90-degree angle, third quarter moon. And so we've got our new drawing. At what time of night would you expect to see a third quarter moon? Now this one is a little tough. Here's the third quarter moon, and notice at 3 p.m. we can't see it at all. At 6 p.m. we can't see it at all. At 9 p.m. we can't see it at all. At midnight, we're just starting to see it come up. At 3 o'clock in the morning, we're going to be able to see it pretty good. And at 6 o'clock, so the time of night we're going to be able to see that is, I don't know whether you want to say really late at night or really early in the morning. That's kind of weird how people think about that. But we're not going to be able to see it all until at the very earliest midnight. So it would be very, very late at night, or consequently early in the morning, before this is going to pop up and we can view them. Okay, and notice all of our waning moons here. Those are the ones that are visible during the morning hours. Okay, so that's that one. During what moon phases will the moon appear on the right-hand side of the sun? Well, let's get our sun out and let's just look at this. Which moons? All of these are to the left-hand side of the sun. All of these are to the right-hand side of the sun. So the answer is the waning moons are to the right-hand side of the sun. You can use this for every one of these. What moon phases could you possibly see at sunrise? Again, move this to sunrise. That's right when the sun's coming up on the horizon. And the answer is going to be our waning moons. Any of these moons are going to be up in the sky during those really early morning hours. And we know from our moon data first look that all of those waning moons that I recorded, I found in the morning hours, and that's why. Tell the time of day you'll never see a third quarter moon. Well, let's focus on our third quarter moon. Okay? Notice the third quarter moon, if it's morning during the day, you can see it really easy up there. But anytime afternoon, 12 p.m., it's right on the horizon. Anytime in the afternoon, it is going to be disappearing. So when it says tell a time of day that you'll never see a third quarter moon, it's going to be in the afternoon hours because it's dipped below the horizon. Next one, you see a full moon in the southeast sky. What time is it? Well, let's get our full moon and let's put it in the southeast sky. Now, this is a little tricky because we can't see the sun, but we can cheat it, and we can go right there. And if this is the 6 o'clock position, this is going to be the 9 o'clock position. So it would be 9 p.m. to have a full moon in the southeast sky. Number 11, the sun-moon angle is 90 degrees, and you see the moon in the morning. What moon do you see? Okay? If we know the sun-moon angle is 90 degrees, we know it's either a third quarter or a first quarter because those are our two 90-degree angle moons. And we know it's morning. There's only one of those that is going to be up in the sky, and that's a third quarter because the first quarter is down here below the horizon, and we couldn't see it at that time. It is 3 p.m., and you see a moon directly east. What moon do you see? Time minder. Sun to 3 p.m. Directly east is going to be right there. There's only one moon on here that we're going to see directly east at that time, and that is the waxing gibbous moon. And finally, you see a full moon directly south. What time is it? We move the full moon directly south, and then again, we don't have our sun up here, so it's got to be sometime at night. And if we look at that, it's the opposite of 12 p.m., so it's going to be 12 a.m. or midnight. So anytime we're drawing these moons on these ecliptics like this, like we did on the first 3 or 4 here, you use this. This will work on most every question on the test. So good luck on completing your Where Are the Moon and the Sun.